All right. So we're working with, we're not working with more. That's later. We're starting with angular and linear velocity. So to explain angular velocity, I'm going to go to YouTube here. And Professor Dave, I think his name is Professor Dave. Professor Dave, yeah. He has some good graphics. So I'm just going to show the graphics and explain the graphics to you. So, okay, yeah. Okay, so I should really mute him. Pause that. I don't want him talking. I just want to talk about his graphics. Okay, because the way he explains it isn't the exact way I explain it. But angular velocity is velocity as something is moving in a circular direction. So when you go counterclockwise, then that's a positive angular motion. And when you go clockwise, it's a negative angular motion. So usually we start at the positive x-axis and we can go through all four quadrants, okay? And our angle will be theta, okay? So our angle will be theta. Now, radians we discussed last time. So when we do our angles, most of the time when we're doing angular velocity, we'll be talking about radians, not degrees. Every once in a while, we might throw degrees in there, but for the most part, we're talking about radians. So you have to think in radian format. Okay? Got to think in radian format, which we did last time. We converted degrees to radians. Okay, so going around one time in a circle is 2 pi radians. That's super huge important to know today. That one time around is 2 pi radians. So if we go a quarter of a turn, it's pi over 2 because it's 1/4 of 2 pi. Okay, so angular velocity is, because normal velocity is change in how far you went over change in time. Well, angular velocity is change here. Let's pause it. It's change in our angle divided by change in time. How many radians we went over how long it took us to go. Okay? How many radians we went over how long it took us to go that far. So, I think that's all that I need from Professor Dave. Radians per second. Yeah, we'll get out of Professor Dave and go back to here. So, let's say that I'm moving around this circle one whole time, one revolution around the circle, and it takes 15 seconds to go around that circle. Okay? I go one revolution all the way around that circle, and it takes 15 seconds. And I want to find the angular velocity. Angular velocity is kind of a W type of thing. It's a Greek letter. I don't know what the name of the Greek letter is just off the top of my head, but it's kind of a W looking thing. And W equals the angle that we have traveled divided by the time. So how far we traveled divided by the time. So now, one revolution is not in radian format. Okay, we need it in radian format to be an angular velocity. Okay, so one revolution, we just said just a little bit ago, is how far in radians? 2 pi. There's 2 pi radians in one revolution. There's 2 pi radians in one revolution. So our angular velocity is 2 pi radians over 15 seconds. Okay, 2 pi radians over 15 seconds. That's our angular velocity in this concept. Okay, now let's say that you have a wheel going around. Well, that's negative. Let's go positive. You have a wheel going around, and we want to know how fast it is going across the ground, not how fast the wheel is spinning. Okay? So let's say a wheel spins at 1 revolution per 2 seconds. How fast does the wheel go in miles per hour? If a wheel goes 1 revolution every 2 seconds, how fast does it go in miles per hour? Now there's one big concept we need to know, one big thing that we need to know. Okay? If something is going around, okay, in 2 seconds, okay, does it make a difference how big that wheel is? It definitely does. A big wheel going around in 2 seconds is going to go a lot faster than a little tiny wheel going around in 2 seconds. Okay? Because a little tiny wheel only has a little bit of circumference to go around. A big wheel has a big circumference to go around. Okay? So we need to know the radius of the wheel. Okay? So let's say the radius of this wheel is like 12 inches. Okay? The radius of the wheel is 12 inches. How fast does a wheel go around? Well, or how fast does a wheel go in miles per hour? How fast does it push a car? Now, angular velocity is going around. When we're actually figuring out how fast it pushes a vehicle, that's called linear velocity. And linear velocity is velocity, which is change in x over change in time. Okay? Well, we need to figure out how far it goes. So it's going to be the angular velocity times the radius divided by the time. That's what linear velocity would be. The angular velocity times the radius divided by the time. Well, actually, oops, I did that wrong. Angular velocity times the radius. Because angular velocity is already measured in like radians per second. So if we take it times the radius, then we could figure out how far it is. Okay, so let's take this example of this wheel spinning. If I want to find the velocity and I know it's going 1 revolution every 2 seconds, and I want to change it to miles per hour, I got to change this into angular velocity. So 1 revolution is what? How many radians? 2 pi radians in 1 revolution. Radians canceled, so now I have radians per second, right? So now if I have radians per second, I want to get rid of my radians. Well, radian is how big, did we say the first day we introduced radians? The length of a radian is the same as the length of the radius. So radian is a radius. So in 1 or 12 inches in our radius cancels the radians. So that wheel is going 12 inches times 2 pi divided by 2 seconds. So it's now inches per second. What's our measurement we wanted in? Miles per hour. I got to change inches to miles. How many inches are in a mile? I don't know. How many inches are in a foot? 12. I know there are 12 inches in 1 foot. Inches cancel. Now I have feet per second. How many feet are in a mile? This one you will have to know. This one you'll have to memorize. Yes, Andrew Comas, you are right on the ball today. 5,280 feet in 1 mile. And yes, you will have to memorize that conversion. 5,280 feet in a mile. So get that into your brains. Okay, so now we have miles per second. Now I need miles per hour. How many seconds are in an hour? You could figure that out, but let's go minutes first. How many seconds are in a minute? 60 seconds in 1 minute. And there are 60 minutes in 1 hour. So minutes cancels with minutes, seconds cancels with seconds, and now I have miles per hour. So on your calculator, somebody please take 2 times pi, which you get 6.28 something, 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 times 60 and times 60 again. So whatever 3,600 is times 2 pi. And then divide it by 2 for the seconds. Press equals, divided by 12, press equals, and divided by 5,280 and press equals. So how fast is that wheel going? If it goes 1 revolution in 2 seconds, it's moving along pretty good, isn't it? How fast is it going? Is it going 100 miles per hour? Some of you are pressing buttons on your calculator, but you are not confident in your answer, so you're just not offering up an answer. So you take 2 times pi times 12 times 60 times 60, divided by 2, press equals, divided by 12, press equals. Oh, I guess my two 12s can cancel. So really, and these two 2's can cancel. So it's pi times 60 divided by 5280 in this case. Not all the time will things cancel that nicely, but this time it did. So it's basically 3,600 times pi divided by 5280. What do you get? 3,600 times pi divided by 5280. So it's really actually not going that fast. 2 miles an hour? Yeah. If it goes 1 revolution in 2 seconds, it's not going that fast. 2 point what miles per hour? 2.14 miles per hour. Yeah. We're going to take a table saw and figure out how fast the blade goes on a table saw. I about cut off this finger on a table saw this summer. I can go like that and barely feel it because I cut some nerves in it. Yeah, table saws, not very friendly little things. Okay, so we'll make you guys do the vocabulary, figure out the vocabulary. But what we're going to do on today's assignment is do a bunch of unit conversion ratios. Okay, you're going to be canceling units. Okay, revolutions cancel with revolutions. 4 pi times 2 pi is 8 pi. And then we're left with what per what? Well, we're left with radians per second. So you'll have several problems like that where you're canceling. And then you're converting revolutions per minute to radians per minute. Now, how do I convert from revolutions to radians? Because I have 35 revolutions per 1 minute. And I want to multiply that by something to get, in the end, radians per minute. Well, minutes and minutes are fine, but revolutions has to change to radians. How many radians are in a revolution? 2 pi. 2 pi radians per 1 revolution. Your revolutions cancel. Now we have radians per minute. So 35 times 2 pi is 70 pi. Round to the nearest tenth. You'll have to do that on your calculators. Okay? So you'll have 7 problems like that. And then a windmill for generating electricity has a blade that is 30 feet long. Depending on the wind, it rotates at various velocities. Find the angular velocity in radians per second for the tip of the blade if the windmill is rotating at 90 revolutions per second. So we're at 90 revolutions per 1 second. And I want to get it into radians per second. How do I change from revolutions to radians? If you don't know by now, you haven't been paying attention today. Multiply by 2 pi. 2 pi radians per 1 revolution. Revolutions cancel. It's 180 pi radians per second. But they have this 30 feet long in there. What does that have to do with the problem? Well, an angular velocity, the length, it could be little tiny and go around or big and huge and go around. Does it matter how long it is when you're calculating how fast it's going around? And the answer is no, it doesn't matter. Now, if you convert angular velocity to linear velocity and make that thing go down the road in a straight direction, does the length of it matter? And the answer is yes. So linear velocity, you need the radius or the diameter. Angular velocity, you don't. Okay? So you'll have a couple of those. And then you'll have a saw blade problem. And a saw blade is linear velocity because we're looking for miles per hour, not radians per whatever. Okay? So a typical saw blade rotates at 3,200 revolutions per minute. So you start out with revolutions per minute. When you're done, when you see revolutions per minute, you always got to think, I got to change it into radians. Okay? How many radians are in 1 revolution? 2 pi. 2 pi radians in 1 revolution. Revolutions cancel. Now I got to get rid of radians because I want it in miles. And I know I have a 14-inch diameter blade. If I have a 14-inch diameter blade, I need to know the radius. What is the radius? So I can get rid of my radians. 7. 7 inches is my 1 radius. My radius and radians cancel because the length of a radius is the same as the length of a radian of a circle. Okay. Now, I have inches per minute. I need miles per hour. How many inches are in a foot? 12 inches in 1 foot. How many feet in a mile? 5,280 feet in 1 mile. I have miles per minute. I need to change it to miles per hour. I know there are 60 minutes in 1 hour. So minutes and minutes cancel. Inches and inches cancel. Feet and feet cancel. I have miles per hour. So you take 3,200 times 2 times pi times 7 times 60. Take that divided by 12 divided by 5280. Okay? And then you work that out, and you should get 133.3 miles per hour. Okay? So a saw blade goes really, really fast. Okay. There we go. All right. That's it for the first learning.